Welcome, everyone. We finally present to you a year's worth of hard work, NewsMaven. This is Jannah, Nirmeen, Mirna, Farah, Maya, and Layla. And in collaboration with Microsoft, we've created something revolutionary for how we consume information. Now, picture this. Now, picture this. You have a question in mind. So you open up the news. You're searching for one simple answer, but you find yourself jumping from one article to the next, trying to find this answer, but all you get is scattered, disconnected information. And why? Why is this the case? It's because we're drowning in information, yet ironically, we're still starving for knowledge. What we need is an AI assistant, a personal journalist, someone who connects all these dots, reads all these articles, and gives you the exact answer that you need. But at this stage, you might be thinking, why not just ask any large language model? ChatGPT, for example. They make summaries, and they also answer your questions. Problem solved, right? Not so fast. Let me explain to you why these models fall short. First of all, they require intensive training time, let alone the training costs. And the result? Disconnected and irrelevant information that's not up to date. And this right here is where NewsMaven comes into stage. NewsMaven is not just like any other AI model. It's a game changer. It's not an app that gives you just the answer. It offers smooth document integration. It offers smooth updates without the retraining costs or the web scraping hassle. And also, it's a plug-and-play architecture. And most of all, it gives you the up-to-date information that you want just when you ask for it. But wait, this is not all. NewsMaven actually can give you information from vast resources, whether it's breaking news or niche topics. In fact, as we speak, we're gathering our articles from 4,000 plus news sources, including but not limited to CNN, BBC News, Fox News, Al Jazeera, Al Arabiya News. But how do we do this? It's the magic word, RAG, or as we call it, Retrieval Augmented Generation. So what is Retrieval Augmented Generation? From the name, it retrieves and it augments. So basically, a user asks a question, documents are retrieved, they are passed to the LLM, and here you are with the response. Now, we understood the problem and the solution. Let us walk through a very typical scenario. A user is curious to know, will Mohamed Salah leave Liverpool? What do? They open up their AI personal assistant and they ask away. NewsMaven, in a few seconds, give them the answer that they want. But us, the developers of NewsMaven, we need to evaluate this answer. We don't just care about the answer. We care about the right answer. So in order to be able to make sure we're giving the right answer, we need to evaluate our model as well as measure our performance. But before we see how we can do that, let's first understand what do we need to be able to evaluate our model.
So to evaluate the performance of our RAG model, we need 4 parameters: the question, answer, ground truth, and retrieved documents, or what we refer to as context. Now we know what parameters we need, but the challenge lies in acquiring a data set that fits our needs. It should be large enough, comprehensive, unbiased, and after our model's training date. So let's walk you through the journey of getting our data set. We first started by searching for existing data sets, but couldn't find any that fits our needs. So guess what? We decided to do our own data set. We selected random articles from a very large collection and generated 200 random questions on those articles. Afterwards, we meticulously searched for their answers, a process we refer to as human annotation. Then, we are ready to run now our model and evaluate the answers. Every time we run our model, we expand our data set by including the context and answer. Afterwards, we ran RAGAS framework on the data set to get our metrics. To evaluate the performance of our RAG model, we use 4 simple metrics. Context recall, which measures if the selected items are relevant or not. Answer relevancy, which measures if the answer is actually relevant to the query or not. Faithfulness, which quantifies how grounded the answer is in the context. And finally, context precision, which checks if the generated answer is in the higher level of the ground truth items or not. Now, we are ready to evaluate each and every step of the magic behind this whole process, our architecture. But before diving in, let's walk you through the inspirations of this process. First of all, we were inspired by agentic RAG, a model that automatically generates and retrieves so that it makes it easier for the user. CRAG, or corrective RAG, which refines or self-evaluates the retrieved documents. Self-RAG, which evaluates or refines the generated responses. Now that we have our inspirations, let us think about how we were able to build this model. We were able to build this model using LangGraph, so that we structured our architecture as nodes, so that our architecture is both decoupled and modular. But to orchestrate the flow between these nodes, we need an agent, the maestro that seamlessly orchestrates the flow between these nodes. It stores and tracks the state at every stage. Also, it takes decisive and informed actions to guide the flow effectively. Now that we have our agent, it's time to look for our documents. We use an API called newsapi.ai to fetch different news articles. And the great thing about it is that it retrieves 100+ articles per run. And guess what? The run just takes 10 seconds.
So now that we have our documents ready, we needed to explore summarization and categorization, as we assumed that incorporating them to our data would reduce our model's hallucination and also increase the speed of the retrieval. And in order to validate this, we decided to test our model on 4 different scenarios that we would be discussing later. So to effectively implement summarization and categorization, we needed a model capable of handling large context and processing entire articles efficiently. And after thorough research, we have found out that Llama 3.1 is the best fit for our task due to its large input context window of 124,000 tokens. And although Llama 3.1 met our needs, further optimization was needed in order to ensure consistent output quality.
So, speaking of the model parameters and its evaluation, we focused into 2. First, the context length. To support full input context length, we faced a big challenge with our GPUs. Smaller window often led the model to hallucinate or deviate from the prompt, especially when accessing larger articles. To solve this issue, we fixed the input context length, which effectively enhanced our output. Second, the chunk size. To handle larger articles, we adopted a chunk-based approach, where each document is divided into a set of characters, summarized individually, and the summary of each chunk is appended to the subsequent chunk before processing. And with that, we have a good quality output. And to evaluate our summaries, we adopted BERT score, which is a robust metric for assessing the semantic similarity between the original document and its summary. We then proceeded with hyperparameter fine-tuning until we yielded impressive results. And with that, we have our summaries.
Now that we have the documents ready with their various formats, we want to be able to store them somewhere. And computers don't understand words like you and I do. So we needed to map these words into numbers or vector embeddings. The vector embeddings are stored in a vector database, and our database of choice is Milvus. Milvus stores 2 types of vector embeddings: the sparse vectors, which captures the keywords and the exact matches.
the dense embeddings which capture the semantics and the meanings behind these words. That way, we are able to store our documents in full context. We know everything about it. Okay, now let's get into how this whole process works. The user starts by asking a question. This triggers the retrieval node. This is where the magic happens. The agent searches the database for the relevant answer. But how does it do that? We utilize the embeddings. In the embeddings, we perform both search by keyword and dense. And using a weighted re-ranker, we take the top K documents that are most likely to contain the answer. And we wanted to optimize this process further. And to do that, we wanted to optimize the searching. In order to do that, we tried 4 different approaches. Storing and retrieving documents only, storing and retrieving summaries only, storing and retrieving categorized documents, and categorized summaries. Our first initial assumption was that categorized summaries would provide the best results. But to our surprise, documents only provided the best results, outperforming the 3 other approaches, achieving over 90% score in answer relevancy and context recall. These 2 scores not only highlight the accuracy of a RAG model, they highlight how a RAG is able to adapt to different or diverse questions. And with that, we were done with the retrieval stage.
Okay, so now we have retrieved the documents. Now we want to be able to select only certain relevant documents that are relevant to the user query. We do that in the refinement process, which was inspired by CRAG. We initially take separate documents and we separate them into manageable chunks. Afterwards, we take each chunk and pass it to Microsoft's cross-encoder to extract the relevant information. We then fetch the top-end chunks based on the semantic similarity score. We initially started with Google Fancy5's model. However, it showed very poor results, giving us only 39% in terms of faithfulness. However, after some research, we decided to go forward with Microsoft's cross-encoder, and it did not disappoint because it gave us 76.5% in terms of faithfulness. And now we're done with the refinement process, and we do actually have the refined chunks. However, we want to assess the relevancy of those refined chunks in terms of the user query. And how do we do that? Using the document's relevancy. We use another node which actually assesses the document's relevancy to the user's query. However, if the documents are not relevant, we're able to rewrite the prompt to re-retrieve the documents once again. And if the documents are actually relevant, we're able to go to the next stage, which is this generation stage. Now, the generation stage is where we have the frozen LLM. This frozen LLM, we take the user query alongside the refined and relevant chunks, and we pass them to any LLM. Which LLM do we say? We could go forward with GPT 3.5, 4, Gemini, and Llama. And why is that? It's because our RAG pipeline is actually modular, and it does support plug-and-play architecture. Now, after we have the generated content, we want to be able to assess the generated content itself in terms of the user query. And how do we do that? We pass it to another node, which is the hallucination grader. And if actually the generated content does hallucinate indeed, we write the prompt and we take the user's prompt alongside the generated content, alongside the retrieved and refined chunks, and we pass them to the LLM. If the output is not actually a hallucination, we're able now to display it to the user. And we're able to answer the question that was initially asked, that Mohamed Salah is now open to a 1-year contract extension with Liverpool until 2026.
Presentation is not done. Okay, so now get ready to meet NewsMaven, where a cutting-edge technology comes alive to keep you informed like never before. Let's walk you through its exciting features. First, the sign-up. You can sign up using your name, email, and a password of choice. And once signed up, logging in is as simple as entering your email and password. But wait, what if you forgot your password?
No worries, NewsMaven got your back. If you ever forget your password, simply type in your email to receive a one-time PIN, enter it correctly, and voila, you can reset your password and regain access to all amazing features in NewsMaven.
Want to keep things up to date? Head to the settings page. Head to the settings page where you can update or view your name, email, and your password. And now that we all set up, let's watch our chatbot in action. Imagine this. You're curious to know why did Israel strike Lebanon? Why did Israel strike Lebanon? So you open a new chat and you shoot your question. Instantly, the chatbot replies with the most relevant and recent information. And even when you ask a follow-up question, like, what is the impact of the strike? The chatbot dives deeper, giving more insights and continuing the conversation until you are satisfied. And once the conversation is done, what happens? Is it gone forever? Can you revisit it later? Let's find out.
Well, the conversation did not end there. Another amazing feature of NewsMaven is that you can continue any of your previous chats. So select the chat that you want to continue and revisit, and you're back to the same context, ready to ask more questions. So feel free to continue your conversation without worrying about losing the thread. To conclude, we are pleased to showcase the successful completion of all our capstone requirements. This includes the community deployment application that you have just seen, and also our research paper that include our findings and methods. We also plan to submit our research paper for publication to ACL. And with that, we mark the end of all our hard work, and thank you all for listening.